Okay, hello everyone. We've got very full rooms. I'm going to speak as loud as I can. And hopefully Zoom can also pick me up and volumes are all okay. Welcome to our workshop today. We're going to look at deploying a web application using Kubernetes. My name is Lewis Sampson. I'm from SDFC UKRI. And then in the room we have Laura and Piper, who are also from Rutherford Institute. They'll also help out. We're going to switch presenters and stuff like that throughout the slides as well. So you'll get to hear from everybody. Alex Lubbock will also be joining us later on. He's currently giving a talk for the first half of today. Cool. So the aim of today is kind of introduce a lot of the basics of what is Kubernetes to start with, going over a lot of the infrastructure, why you use it, and things like that. Before I actually get into it, I'll do some housekeeping. So questions-wise, in the room, if you have any questions, please feel free to raise your hands. Either Piper or Laura will come around and help you, or online via the Slack channel, or via the Slido, or the Zoom, or yeah, Slido or Slack is the aim. There is a Slack channel for the Kubernetes workshop, which has also got links to the GitHub pages and GitHub in general that you might need. There's a little bit of prerequisites in terms of downloading and installing some stuff. You can see all that in there. But we can cover stuff. Anyway, yeah, so into Kubernetes, a little bit about what it is. So for anyone who is not familiar with it, it is a container orchestration platform. It's got a lot of benefits in terms of like advancing the use of containerized applications, because it manages a lot of the issues and complexities around it. The benefits come into the fact that it's like a declarative configuration, so you set the desired state, and then ideally Kubernetes manages everything else. The few things you have to make sure you configure correctly, but the majority of things are all sorted out by Kubernetes, especially considering things like networking security, which are usually really awkward to do sort of manually between containerized stuff. It also helps dealing with like rolling updates and keeping updating images and containers and those kind of things. There's a various different sort of use cases for Kubernetes out there. Some of the big ones are things like microservices, high traffic websites, as well as sort of using like hybrid environments. They will also work well over Kubernetes because it manages that. So if you've got a cloud and a physical on-premises stuff, Kubernetes clusters can kind of span that side of things. So there's a little bit about the why. I'm now going to go through some of the physical architecture of like what a Kubernetes thing is. So Kubernetes is built up of a bunch of nodes. These could be physical or virtual nodes. But we divide into two main parts. You've got control plane nodes and worker nodes. Control plane is considered like the brain of your Kubernetes. This handles a lot of things that we discussed. So the maintenance and state of your pods and nodes that you're running. So the control node itself, as I said, is the brain. It has a few components in it. You interact with it via the API server, and then the other things are kind of underneath, self-managing and running things. Yeah, the scheduler thing is the scheduler will decide where you want to put pods and where you want to put nodes. You can configure this quite specifically, so you can have only certain jobs run on certain areas of your hardware or infrastructure that you've got set up. Then worker nodes are where you actually run things. So where you actually have pods and workloads that are running within your cluster. These typically go up to worker nodes. You kind of keep this separation mainly for high availability, to keep things running smoothly and robustly. You try to separate the two services. On your worker nodes, you have kubelet, and that's the communication between the API server and the worker node itself. And then you have within that, you also have a container runtime. So if it's in Docker, that runs within the worker node itself. And then kube-proxy is what we call, which handles the routing and networking between services. So that's the quite high-level physical or virtual side of things. This is a diagram taken from the Kubernetes website. It's quite a lot going on, but it kind of gives you a bit of a visualization of how the work is sort of split. You have, as I said, you have this brain area, control plane, and then you have these worker nodes. You can have many worker nodes. For the control planes, you typically have at least 3. This is again to do with like high availability, keeping things up and running, and sort of like production level stuff, keeping things reliable and robust. Yeah, so if you follow that link, you can see the actual one, and you can have a little bit more in depth into like a few of the concepts in and around Kubernetes. But that's the higher level stuff. So now down to some of the lower level stuff, the actual resources that you then run within these nodes or on these nodes. Containers, if you're familiar with containers, then this is probably a bit obvious, but this is just a way to wrap up applications to have consistent environments, isolating things. As I said, there's an efficiency benefit here, so you're not having to spin up a whole virtual machine to run your application. You've got an image that is packaged and containerized and has everything that it needs within that, and only what it needs within that. So efficiently succeeding. Containers have been used for a long time, building block. For Kubernetes, containers are run within pods, so pods are the smallest bit of actual deployable stuff you can put onto a Kubernetes cluster. So you don't put an individual container, you put a pod itself.
If somebody signed into Zoom, could you please mute?
Sorry.
No, it's not me.
It was me. Oh, are we all good? Seems like they've done work. Okay, cool. All right.
Brilliant, thank you.
So yeah, pods, smallest deployable units. You can deploy a pod onto Kubernetes. This would describe what container you want to run and maybe how you want to run it. It's good to remember pods are ephemeral. They die, they kind of disappear. They're an individual instance. They're not maintained, they're not persistent. But typically they have a single container in it, and then maybe you have like an initialization or a sidecar container with it as well, depending on what your application you're running in there is. I think this analogy at the bottom is quite good. It's a wrapper around containers, and Kubernetes can then actually manage it so it can handle the bits that it needs to handle. So the step up from that is then the deployment. So this is for lifecycle management of applications within your cluster. This would be, you would describe again the desired state of what you want Kubernetes to have. You might say, I want 3 versions of this pod. Kubernetes manages it, keeps up that many. If one falls down, so the pods are ephemeral, as I said, it might die, disappear. It will reproduce it. It will create another one. It maintains these via things called replica sets. So deployment will create a replica set, which will create your pods. This is really useful for things like updates. So then you can have, if you've got multiple pods, it can update one at a time. So if you're updating the version or something like that, you can have this high availability up. And this is again why it's quite useful for high traffic web applications or things like that, where you've got a lot of stuff coming through at the same time. You want to maintain sort of 100% uptime if you can. Yeah, I don't think there was anything else. So then try like tying a few of these things together from like the hardware side to like the actual resources side. How would these work? So you would submit a deployment via a manifest YAML, and so you put kubectl apply-f, and then the file that you want to apply to the cluster. The API server who picks it up through kubectl will take that request. It will realize, okay, there's now a deployment on the cluster, and it sends this off to the scheduler, picks a node, puts the pods on the node. The controller manager sits there, watches, makes sure that this desired state stays up to date. And again, if something fails or crashes, it does its best to try and reproduce, bring it back up. Kubelet on the node itself then pulls the container image, starts running the pod, starts doing whatever it is that is configured to do. So kubelet goes to pod gets containers, and then kubeproxy sits there and networks everything that needs to go through. Yeah, idea of this workshop, we'll see a lot of this stuff in action. So hopefully a lot of that will make things a bit more clear when we get to it later on. So again, more onto this workshop. So this workshop, we're using Minikube. Minikube is a really small, lightweight version of Kubernetes. It is perfect for development and testing, perfect for local environments, not great for production level stuff. It's lightweight, it's for experiments, it's for playing around with. And so there's a bit of a difference between standard Kubernetes, as I described, and Minikube. So for example, control plane runs inside the Minikube VM, work node also inside the same Minikube VM. Basically everything is inside there. kubectl connect from your host to Minikube. So it connects to the API server with kubectl or the Minikube command. It's kind of a wrapper around the same thing. And then everything is within this. So just summarizing the differences there. We're on a single node setup, so everything is in one node. If you're running Minikube, networking is then a lot simpler. It's a lot faster to spin up and test these things. So that's what we've used it for the workshop today. Right, so a summary of stuff that we've explained so far. Essentially, what the clusters are made out of, so the different types of nodes, the core concepts, introduce Minikube, and then the difference of Minikube. So now we will step into actually running some of this stuff.
Before we do, shall we take some questions on
yeah, that's a really good point.
Yeah, so Slido, Slack, or you can raise your hand in the room if you've got anything you wanted to ask.
You say that Minikube's used more for just like testing out stuff. Is there ever any example of for production, smaller tools and things that are powerful?
I think you can use it to be a little bit more powerful, but I think it's designed in a way that you wouldn't use it for that. There are other things that you can use to deploy things easily, sort of like the middle level stuff.
So like K3s?
Yeah. So things like that, or there is like some online stuff as well, like different providers offer different things. But Minikube is,
We will probably run, based on how successful this is, if you go away and you hate it, probably not, but we will probably try and run another workshop at a different event on how to actually build a cluster. But it's complicated.
It can be quite complicated, so sorry.
Yeah, I wondered if it was possible, if you've got a Docker setup, could you use Minikube in place of Docker so that if you come to that point where you want to expand out into Kubernetes, it's an easier process? Is that a sensible thought?
Yes, you can. And I think we will cover that a little bit today. You can use it for that. It is very useful. It depends probably on a little bit of how you prefer to work, but that would be
Okay.
Yeah. Sure. Any other questions from the room? Any questions online?
There's nothing online. Sorry, I didn't see your hand, so you go ahead.
Thanks. I'm just wondering, so I'm like, I've been in a way trying to use like containers less and less in what I do.
Okay.
But I do see like, so I work on like a lot of machine learning, and I do see Kubernetes popping up like here and there again and again. I guess like, is there something like good enough about like Kubernetes that like I should maybe consider also adopting like a containerized workflow? Because I guess that like for me, for example, I'd probably end up switching both to making containers for my workflow and then maintaining them with the Kubernetes workflow. So I don't know if you just have thoughts on that, because
So me personally, I haven't worked with Kubernetes and machine learning, but I know that there is a big popularity there. And I think it's partly to do with the Kubernetes is very scalable. So for example, if you had a lot of very heavy machine learning that you needed to run, you could have Kubernetes. If you had it on a cloud environment, spin up a bunch of extra nodes, add them on, run through these workflows, and then sort of cloud burst back down. So there's basically a flexibility and an efficiency there that could be useful in terms of how much computing or resources that you're using. I think it's similar to like the idea of using a container is that it becomes a little bit more efficient than running it just on your VM. But if that isn't an impact on the actual work that you're doing, then it might not be worth the extra overhead of arranging it and managing it. So yeah, there is a lot of interest in the general area of Kubernetes for machine learning. So
can I just add a couple of points? So for your question on Docker, I would say use Docker unless you have more than one application. When you start to get to like more than one application, then Kubernetes is your friend.
So the reason I asked that, if we have a setup for a small Jupyter service, and it looks like we want to build a Kubernetes thing so we can put the workers into a sort of dynamic system. And at the moment it doesn't do that. And should I have started in Minikube for that kind of idea? And then I could easily come out into an extensible environment. So yeah.
So
Yes, no,
yeah, again, yeah, it's a little bit. Yes, no, I think you would basically, if it worked in Docker, it would probably work in full Kubernetes as well. But it depends again on the overhead or the time you've got to set up and manage a Kubernetes cluster, or if you have somebody who can do it for you, or you can afford an external provider or something like that. If you just have a cluster running, and you should always be able to plug and play with a lot of this stuff. So if you've got images that work. Another thing I didn't mention, but Kubernetes integrates quite well with GitOps and like CI/CD and stuff like that. So if you're doing anything in that realm for your Docker images, you can have it that you make a push commit. It creates a Docker image that gets straight pushed into your Kubernetes cluster, and you can deploy it and look at it like that.
That works very well with.
Yeah. Okay.
And then I had one point for machine learning. I totally agree. It's very difficult to containerize stuff, especially when you've got CUDA dependencies, you want to use GPU. So there's a lot of interest in ML and Kubernetes, as Lewis said. I think it's more for the MLOps side. So when you've got a machine learning pipeline that you're running, you want to run loads of configuration on it. For the development side of it, I probably wouldn't suggest it.
Yeah, so we use Kubernetes in deploying training models. You can use Kubeflow to spit up these experiments with I think a random mix. There were a range of them, so that's kind of a good way of doing it. You can do a manual on either.
Yeah. Cool. Right. So I think at this point we're gonna move on to some of our lessons that we're going to go through today, and I'm going to hand over to Piper.
Yep.
If you need a minute to get set up, again, ideally everybody has Minikube and GPU available. We know that that's not easy sometimes, privileges or whatever on laptops is not always straightforward, but hopefully everyone has been able to get it installed one way or another. If not, we should still have a demonstration that you can see, and so the idea should be like transferable like that.
Can this install the non-secret access to my laptop?
Pardon?
Can I install the non-secret access?
No. If you look at the Kubernetes workshop channel, some kind person, I think it's Jack Frost, if he's here, thank you, has investigated doing it with GitHub code space, and he shared a link to do it. So we've got a few people trying out GitHub code space. So yeah, you. It's in the Slack. I'll read. Oh, thank you, Jack. Yeah, perfect.
Yeah, thank you, Lewis. That's great. But if you haven't got it installed or don't want to, I will be going through all the commands and showing you in action, so you can just follow along. And it's also in both the slides, and I've linked in the Slack channel. We have it in an MK Docs sort of left page of these lessons we're going to be covering today. Okay, so from Lewis's talk, there's a lot of different concepts, which hopefully some of them will become clear. But I think so the main two points of contact we're going to have practically is the Minikube command for talking to Minikubes, and also the kubectl kubectl command, which is to talk to the API server on the Minikube. So we'll mainly be working from the command line, and this is obviously useful because a lot of times when the cluster you're working on won't be in a headless, so there won't be a display you can work with. However, we thought it'd be good to show you have some graphical interface, so people who aren't so familiar with that side of things can check on the status and see the different parts, workings of the Minikube cluster. And to do that, we're going to use what's the official Kubernetes dashboard, which is included with Minikube. So Minikube includes a lot of vanilla Kubernetes stuff. Some of it you have to have add-ons for, but the dashboard's included by default. So the first thing we need to do is actually start our Minikube cluster, which you can do using Minikube start. And depending if you've run this before, it might take a minute or two to download images. But for me, it probably should be quite quick.
Do we care where we're doing Minikube starts, or can it be
Anywhere, just somewhere you can clone the workshop repository. We'll need that a bit later.
I've got that clone. Should I go into that workshop repository and run it there?
Doesn't matter. Absolutely fine. But that's you can definitely do it inside it. It shouldn't be. Yeah, maybe later on we need to go inside it to look at the image files. So not a bad idea.
Need any help online? Please put stuff in the Slack channel, and I'll be prepared to help online.
So one thing you probably noticed with Minikube is there's a very heavy use of emojis for everything. So if your terminal doesn't have Unicode, you're probably a bit looks very strange. And at any point, because it's actually quite easy to forget to sort of close this terminal window and forget what's happening, you can always check whether your Minikube server is running just by running Minikube status. And hopefully this is large enough. So please tell me if you want me to make the text bigger or smaller. And this just gives us a very simple overview of what the different components are and confirming that it's now running.
That screen's not on the Zoom channel.
Oh.
I'm following it on Zoom so I can see it without having to look over there. I've only got your previous command.
All right. I see it on Zoom.
Oh, that's weird.
That's weird. I see it on Zoom. I don't know.
Oh, Zoom's crashed.
Okay.
It always chooses the most of them crash.
You can take my seat if it comes.
Yeah.
Yeah, it is easy. Okay, and so to access this dashboard, so we can see get some insight into our Kubernetes cluster, which is now running in this Minikube VM. The command is just Minikube space and then dashboard. So if you run this, it will try and open it in a browser. I'm in Windows Subsystem for Linux, and it doesn't know how to do that. So instead, it just gives me a URL. So depending on how you're running this, it'll either open it in the browser automatically, or you'll have to follow this link, which gives down here. So I can do that with Control plus click.
Okay.
So has everyone got a link or think they can follow something? I see a lot of people who've managed to start Minikube. There's still probably some people still waiting for images to download, but hopefully that'll do while I'm still going through this. And yeah, if you can't access the dashboard, don't worry, because we're going to look at how to get this information from the command line as well. But I just wanted to connect what's in the dashboard to what Lewis was talking about a second ago. So at the moment, there's very little here, and that's because we haven't deployed an application. So that's sort of under this workload, which is all about our deployments. But let me just go down a little bit on the left bar. So what else we can see? So services, these sort of provide our network and how we actually access our deployments, our applications. But what we can actually look at the moment is under cluster. So if I look under cluster in particular nodes, you should hopefully see if your Minikube server is running your Minikube as a single name, and it's got a green dot next to it. So basically, green means it's good, it's running, it's healthy. If it's orange, it means it's changing or updating, and if it's red, it's some failed or error state. And next to it, there's lots of labels, which probably look quite unintelligible to you. These are just automatically assigned when Minikube starts, but we'll look at how we can define our own labels later on. And if you want some more information on your cluster, you can click on it. And then, yeah, this has more detailed information about the operating system and also resource allocation and use. And so if I look down, there's actually, even though we haven't deployed anything, it's listed there's a number of pods which are currently running. And so these are, yeah, basically system services which start automatically. Minikube starts automatically. So I think we saw Lewis mention about kube proxy as well as etcd and the API server. but these are sort of system ones which are normally quite hidden to us. So if I go under workload to the pods, it says there's nothing to show. Does anyone know why I can't see them here? Yeah, so we had someone say the namespace. So in this top bar here, we have it's called the default namespace, and that's what Minikube puts you in by default, and that's what we're going to use throughout this lesson. However, this is sort of a logical division of Kubernetes has, which is quite powerful in general. It's quite an important concept. So all those other system services pods, they're in one called kube system. So if I click on this, then you actually get a list of the running pods. So again, this is under workloads and pods. And those are the same pods which we know are actually running on our Minikube node. Okay, so before closing this, I'm just going to go back to the default namespace. So if you want to check back on this later, when we have deployed the application, you actually see just our application. Okay, so I'm going to go back to the terminal. So, okay, so for the next part, we're going to actually look at deploying an application that Alex wrote for us. I'm not sure, has anyone tried to run the kubectchaos application that was on the GitHub?
I've got one person online, so I've said, can we wait for this magic part?
Okay. Yeah, well, I won't spoil it because I haven't got it running at the moment. But so the first thing we need to do, this is going to be it's sort of a JavaScript app, and it's going to be made as a Docker container. So Kubernetes can work with Docker images, but unlike Docker, it doesn't build it itself. It assumes you've already got the images made. Okay, so you're responsible for making the images. But fortunately, Minikube provides basically a build command which we can use, so we can all keep it in one workflow. Okay, so the first thing we need to do, if you haven't done already, is to clone the workshop repository. So I think I have the.
I can put the workshop in Slack.
Yeah.
It's a public it's public, so
Or will be in the slides. This is lesson 1. So I'm just going to clone this repository. And I'm going to go cd into it.
Oh. Yeah, we did. Sorry, the download speed might be suboptimal.
Okay. It's only a couple of megabytes, so it should be okay.
Anybody got any questions while we're waiting for people to download at this stage?
Yep.
Yeah, the question about the dashboard. Is this like a Minikube feature, or is it?
No, it's actually a Kubernetes feature. Just Minikube provides an easy way for you to start and stop it and access it. Yeah, get a URL for it.
So you can run the dashboard in any Kubernetes.
Yes. Yeah. And there definitely other there's 101 different ways to visualize your Kubernetes cluster. What was that nice one we saw? Was it K9s or?
Oh, K9.
Yeah. If you look up at K9s, it's quite fun.
Is that just spelled K9S?
Yes, I think so. Yeah.
I'm not gonna look.
Yeah.
Okay, no.
So
Yeah,
not
Okay, so within this this repository, there is an image directory, and that's actually where our application source code is. So it's called app.js. We're not going to look at this yet, but we might. Later on, we're going to look at editing it and updating redeploying our application with a different version. So we need to firstly build this Docker image, and to do that, we can use the Minikube image command. So it's Minikube image build, and then just like in Docker, you give it a tag. So I'm going to give it a -t and then local/kubectchaos version 1, and then space, and use another image, and that's just telling the last image is telling it which directory is the build directory. So sorry, I've gone off the screen then, but yeah. Make sure the tag is local/kubechaos:\v1.
Question.
Oh, sorry.
Well, I'm just gonna ask before, I'm assuming that command is using Docker as opposed to Podman. Is there one side violation?
You can, yeah, you can be. Yeah, should be good. You can install the keys. Well, I don't use that. I'm the head anyway.
I did it. It was moved by a word.
Yeah. So if you
So it's from whatever the initial install.
usually there is also then a flag. So if you run that command, it's going to go and download some more. So it's really good to do it as soon as you can. I can't remember off the top of my head, but there we go. I'll go up so you can see the command again if you didn't get it.
The command.
There's a there's the slide. Oh no, will the command be in the slides as well?
Yeah, the commander in the slide,
Yeah.
the documentation as well in the repository. If you click on, if you click at the top of the repository, that bit, you scroll up the page, that bit down there. Click on it.
Yeah. So if any point you want to look back at the commands, in the slides have basically a quick summary of all the commands. So I think we're now, yeah. So you can directly copy this from the slides if you want to.
You like posted the link to the tutorial.
Okay, so hopefully everyone managed to build the image. So and it finished with this done down at the bottom. Has anyone had any issues with that?
Well, it doesn't show me that.
Yeah.
Sometimes the entrance, you make it nice.
Okay, so now we've built the image, we need to actually look at how to define a deployment in Kubernetes. So
Slack, I believe.
a key concept is that Kubernetes has is very directive approach. So you specify the state you want your cluster, your application to have, and the Kubernetes system will work to achieve that. Which means that instead of often running commands by hand, you specify everything via basically a configuration file. And this file is called a manifest. And so we've written one for you already. So if you have a preferred text editor, this manifest file is in the deployment directory. So we're just gonna have a quick look at this. So I'm going to use Vim under deployments, and it's called manifest.yaml.
You don't have to use Vim, by the way. You can use text editor. I know how to polarize it. I don't have that as a fellow Vim user. But this is not Vim users anonymous.
There's going to be one inconsistency, is that my Vim's in dark mode, but hopefully it's still readable. Okay, so there's quite a lot of details here which we don't need to go into, but there's just a couple of key things I want to look at. So basically, this file has 3 different parts. It has one part called a kind of the deployment, and that's pertaining to our application. I'm just going to go down. It has a second part, so this dividing to basically a YAML divider. One called a service, and this is called kubechaos SVC, and this is how we're actually going to interface with our application. And then there's also a third, which is a config map, which we'll look at a lesson after lunch, hopefully. So if I'm just going to go back up to deployment, and the key bit is how this corresponds to the architecture we saw earlier. Is we have a specification and spec, and under spec we have replicas, and so this corresponds to the replica set element. So this tells me that I'm basically going to have this object is going to want to sustain one copy of my application, one pod. And then what is the pod it's going to make? Well, that's under this template, and its specification has a container, and we give it this name of app, and the key line here is this image line. So you'll notice this corresponds to the image we built in Minikube. So this is how Kubernetes knows to use our Docker image we created. And the other thing I wanted to point out is that at the top of this deployment, we've given this a label. So both parts of this label, it's a key value pair. Both parts of these can be anything you want. We've given them something sensible, app and kubecchaos. And this is important. This is a very powerful label selector scheme where we give it the label up here. And if I now go down to where the service is defined, you'll see that it selects according to that label. Okay, so this is how the service knows which deployment and pods to serve. Okay, so we don't need to do anything at the moment with this, so I'm going to exit it, which in Vim is :Q.
One of the most Stack Overflow questions. How do you exit Vim? Anyone wants a little trivia?
Yeah, we just close the terminal window. That also. Okay, and so now we can actually hopefully get everything in place to start up our deployments and to see how simple it is. So this is now where we're going to start using the kubectl command. So kubectl, and then we have apply, and then we need to tell it what file is its configuration file, its manifest. So that's -f option, and then deployment, and press tab just to complete that, and manifest. Okay, so if you now will run this. Okay, so it told us a couple of things. It says it's created this. Okay, I think maybe projects I've run this before. It's telling me that the service is unchanged and the config map is unchanged. I think that's possibly because I run this before. Assuming it's the first time you've run this, it's probably said it's also created the service and the config map for you as well. Okay, and now the final thing to do is actually, so at the moment this is running on our Minikube VM, but there's no real way for us to get at it because this is a separate VM from our local host. But what Minikube does is it provides a way for us to a tunnel to that service. And so to start the Minikube service, we use the Minikube command again, Minikube service, and then we need to put the service name from the manifest file, which was kubecchaos-svc. Okay, so when you run this, it's again, hopefully going to give us the URL. Okay, so it failed to open the URL for me, but it did give me a URL which I can now follow. So actually, this is a port on localhost, which is actually unrelated to the ports we saw in the manifest file because they corresponded to ports in the containers or actually in the Minikube VM. But this is the one we want. So I'm not sure anyone's opened this and see what the application actually does.
What's the command again?
Yeah, it's in the
Minikube service, kubecchaos.
Okay.
Yeah, as I was saying, it's in the slides. You can have access to the slides.
just so we won't go too much into services. Pipe has given a bit of an overview of what they are. For further reading, you can see our documentation on this. We won't have time today if we start going into services and proxy, but yeah.
I think that's
So see if you can open the web page and refresh it a couple of times. If you've got any problems, put your hand up.
How to do that.
They just again. I've not come across
James, I think you've got some port forwarding set up. I don't know whether you could help me.
Yes. So I can do it for the thing. I don't know if we can do it against one
Right, all the work.
So this is as far as I got our testing. The thing is, local host URL. I don't.
No, like,
Right.
so the page is start. So not do we do start? Yeah, okay, well, let me. Go to the website.
Yeah, okay. No, it's not like instructed. Yeah.
So now we've got regularly.
And so, like, it's fine. It might have been wasn't there at that time.
Well, we just took the speakers up. It's fine, but
As long as graphic, can work it.
Yeah. You can look at stuff.
I think it's in that drop down menu.
So, should be right with
That's right.
then check. So
Where are you? Yeah, I'd be interested in that.
How do I put that?
yeah,
I don't think you use it. I just.
that's fine. Try the pod round.
Yeah.
Now, pulled up while I'm thinking about it. I can always. Yeah, I don't go to it. So. Our platform. Microservices architect.
That one.
Running.
Then we had 3 rounds of class.
Which one? Get on. So we have like Dr. Bill. That's what I ended up having to use the ICD, which produces an image, and then staging something. It was just hanging for quite a while. So it took ages to get started, but now it makes itself quite well. And it's one of the probably a lot of relationship and the number of other ones who are into it. It makes a lot of things. Yeah, people know it. And then and then case 3 is the mini version. So the 3 is final product painted have. I think that's
No. Was that the lot? So, maybe. One of
Environment there.
Yeah. I started that.
No, I've managed to get the lesson 0 done. I think the reason that it went trying to do BPM and then
It's nice drawing. Yeah. Let's have a portrait. Let's do it.
No, it didn't. For him, it wasn't manipulative. I don't know if that makes sense. Yeah. So what's good now? I was looking out.
Yeah, it's always going to happen, right? One of those stuff.
How you start and then it landed on. He did not work. I don't know. Yeah, like it did. Yeah. The knife. Yeah.
When's your stupid?
Yeah. Wait 6 minutes. This is a bit. So
I just have it, and I did start.
And outside of it, good.
Yeah, this one.
That's right. We stopped there. Fine.
What I'm hoping is the service wants to
But yeah, actually, no, what you do is you have
Massive. Okay. Okay, so then it's that's right. We don't want to go down that one. So we start different stuff.
I did the build where I had to look at the dashboard. But that
Yeah. We're going to move on. I know some of you haven't got stuff installed, but we'll move on and we'll come round in the next break to help out people.
Yeah, thank you for the patience and also those who have got it working. That's great, and thank you for waiting. Okay, yeah, so this is quite a fun. Some people have seen this working. Basically, every time you refresh this, it comes up with some novel joke or interactive piece, and we can actually see Alex has included this. It tells us what the pod is in Kubernetes is actually serving us this web app. Okay, so we'll actually look at how we can get this information from the command line. So I'm just going to go back to the terminal, and now I'm going to use the kubectl command again to look at how I can actually interact with the deployment, which is now running in the background. So one of the key kubectl directives is get. So I can run kubectl get, and then, for example, pods. So this tells me that I started this. I've got a single pod. It's running, and it's been going for 16 minutes. And this name is basically the application name kubectl and then some unique identifier. And if I look back in my browser window, that should be the same one that served me in the browser. But of course, for you, this is going to be a different identifier. And then remember, this is a Docker container that's running. So you're actually able to, just like a normal Docker container, you can look at the logs for that container. And to do that, you use kubectl logs, and then you need to put the name of the pod that you want to inspect. So for me, this is going to be this one here. So I can copy and paste this kubectl and an identifier. And this is just some very simple logging which the app did, which is basically saying the node to start this application, this JavaScript script, and also that it's running on localhost with 3000. But this isn't the port that I use to access it in the web, because this is the actual container port inside the deployment, which we can't see directly. Okay, so next thing I want to do is a little exercise. So we've got this one pod running. What I'm going to try and do is I'm going to see what happens when I actually delete this pod. So to do that, I can use kubectl delete, and then again this identifier for the pod name.
You need pod, I think, before.
Yeah, thanks.
There's a typo in the slides. Sorry, everyone. Thanks for those who put it on Slack. Yeah, it's delete pod.
Must have copied the slides. Okay, so if I then run kubectl get pods again, well, that's quite surprising. So I can now see that there's still one pod running, but it's got a different identifier. Okay, and it's from 16 minutes to 13 seconds. So does anyone know what happened?
We started.
Yeah, and why was that?
You got one replica.
Yeah. So the manifest said, I always want one replica running. So as soon as it got deleted or it failed, Kubernetes steps in and it creates a new one for us. Okay, which basically is very nice, and this is why Kubernetes is good for high availability stuff, because it means that my service isn't interrupted. Right, I've still got this web server running. Okay, now it's got a different pod serving it, but maybe the user didn't even notice this downtime.
If it is able to spin it up so quickly again, what's the reason for having replicas set higher than one?
Okay, so maybe it's not just me here, but I've got 100, 1,000 people accessing my server. Do I want to distribute the load over different?
So it's like something else is mirrored and it's able to. It drops, it can immediately.
Yeah, and we're actually going to look at that in a sec right now. So yeah, so we can change the so this is called self-healing in Kubernetes, and another really key feature of Kubernetes is the scaling. So you want to be able to handle a lot more requests. Yeah, Laura?
Sorry, just on the self-healing, I just want to make sure, who here has ever had a server fall over, come in to work at 9 AM and everything's broken, you've got a million emails in your inbox asking you. I give you self-healing, everybody. So this is like a really important feature that we wanted to get over in this tutorial of maybe why you should use Kubernetes. That if something goes wrong in the system, you've got a multi-node system, right? If one of your nodes dies, Kubernetes will put a pod on another node. So this is like the real power of Kubernetes. Sorry, Patrick.
Yeah, that's thank you. Yeah, and then so the other really powerful thing is the scaling. So we could have specified in a manifest file a higher number of replicas rather than one. But we can also just, if you want to try it out, do it using kubectl directly. So what I'm going to do is use kubectl, and now this time it's called scale, and the deployment, the name of our deployment, which is kubecchaos, and then the option we need to specify, tell it to apply is -- replicas equals to 3. So that's basically telling it to change the number of replica sets from replicas in our manifest file from 1 to 3. So this is some sort of like local override of the deployment. So I'm going to run this. And then let's run get pods again.
Does the word deployment might refer to like the local folder deployment we have, or is it like a separate word?
That's a special word in this case. Yes. Yeah. But I think normally you would call where you put your manifest file under the deployment directory. But yeah, here it's actually, so I could have done kubectl delete deployment or inspect deployment. There's lots of different options to that.
Yes.
Okay, so those of you who have got it running should hopefully see that there are now 3 replicas. So our original one, or one after that was recreated, which should now be around 4 minutes, and then 2 new ones. So it's quite interesting if you now go back to the web application and see if, well, at the moment, if I'm refreshing this page, I'm still getting served by the same pod. But maybe if I try opening this in a new browser window, I might be able to. Okay, so somehow Kubernetes still does a new request. So in this browser window, I've now got a different pod serving me. And we won't go into the details of this, but basically there's a component called a load balancer, which is responsible for basically directing traffic to different pods when you have lots of different people using your service.
Yeah. Stripe for t-shirt first, sorry.
Just so I fully understand. So if you don't have replication, one instance is running at a time, but if it's filled, it goes to respawn. Whereas if you have replication scalable free, then you have 3 concurrently running. They're all being installed as well.
So yeah, if you have 3,
yeah.
Kubernetes is always trying to get back to the state you've defined. So if you have 3 and 1 dies, it will try to restart the 3. If you have 3 and 2 dies, it will try to get you back to the 3. So whatever state you've said you want, it will always try and get it back. Does that answer your question? You had a question.
Yeah. I get different types of load balancing approach.
Yes, so the question for people online is, are there different types of load balancing approach? Yes, I don't know too many details, but I think the default is round robin. Is that right?
Yeah.
So, but you can. I think for production stuff, knowing how your load balancer work is obviously very important.
Give us an idea of how many pods are really active at a given time. You got a load balancer. Is that happening in its own pod? Is it like a 4-pin pod in addition to the 3 in the replica set?
Yeah, so I think if you'd have to go back to the dashboard and look at the system services, and those are the pods which are doing these kind of basic things.
And then the Kubernetes controller, is that also coming in some pods?
Yes, these different parts are so
only in Minikube.
Okay.
Right, only in Minikube are these things pods. In a big Kubernetes cluster that Lewis described at the start, these things are different components. So a pod is the smallest unit of work of a Kubernetes cluster, and that's the thing that runs your container. Your load balancer is a service that you can set up. What was the other one you asked about? And the control plane is where the API is running. So in Minikube, everything is a pod. When you deploy this on a large architecture, not everything is running as pods. If you look back at our diagram, there's something called kubelet, and these things are actually running as kubelet applications. Yeah, so there's slight subtlety there, but
What are these different things there? These seem to be Kubernetes for the term.
Yeah.
There's a lot of different resources that you can have in Kubernetes. One of them is called a daemon set. So this is similar to a replica set, but it means that it runs it on every node. And so things like kubeproxy and the controller manager and things like that are considered daemon sets. You say if you have them running across, if it's a worker node, it runs across all worker nodes or control nodes, however you set it up. There's a lot. It's a big open space of various different levels of complexity and customization as well. So
yeah, and definitely one of the trade-offs is it is now more complex what you're doing, right? So, but a lot of stuff is abstracted away, but it means that if it all works, it's great because you have a very simple workflow and front end. But yeah, there's definitely more complexity behind the scene. Yep.
When you said it, we just John and told it to make 3 copies of this thing now, and then if you kill one, it tries to get back to having 3. So the manifest file still says we wanted 1. So now you've got a conflict between
Yeah.
He's actually trying to do. So I can imagine this ending up with horrendous debugging things.
So this is really so the question, so basically the concern is that I've gone and specified 3 replicas, but on manifest says 1. There's now, basically you always want a single point of truth. I've got to muck that up. So I would say doing this is not a recommended way to work with your cluster. You always want to work with the declarative approach where you have a config and this is version controlled and it's all very nice. This is more sort of testing and demonstration, I would say.
Once you get very far into it, there's GitOps, which is usually managed by either a tool called Flux or Argo CD. And that would be that's how we deploy stuff to our cluster. So we change it in Git, all gets pulled through into the cluster. There's one source of truth.
But is this change you've just made log somewhere so that when you come across a state like this, you can see that someone did this?
So you've just interacted with the Kubernetes API, right? It's a good question. I actually don't know what Minikube, whether like Lewis, we manage everything in GitOps. So this is just
there's a kubectl edit command.
Right.
Takes you to the YAML, like the manifest YAML
as it currently sees.
I guess. So there, I think.
Yeah. Okay. Yeah, that sounds. Yep.
It's too much that question built up, but
Right.
I guess what I was wondering is within each one of these nodes, is that one machine or box, or could you have a whole collection of boxes per node?
That's a good question. It depends on how you set it up. Normally, it's usually like 1 box per node. But you can start to do really clever things. So, for example, with MIG GPUs, you can use Kubernetes to split a single GPU up into 7 nodes. Yeah, and so you can start doing very weird things at the system level. I would think of it as like where we have it on our cluster, we have 1 virtual machine per node and 1. And they will have their own hardware.
So in that sense, if, for example, you were building a web app, you wanted it to scale, and for example, you had Postgres, would that be its own node? And then
no, it would be a pod on a node. So your nodes can run multiple pods.
Yes, your nodes can run separate. It should, because then and then the pods running your entire application, you don't lose part of your application.
Right. So it's almost parallel if you were using Docker Compose.
Yes.
So each one of those is a node.
No, each one is pod. The node is like your big box, and then your pods are like your containers running. Now you are right, and at one stage your node is going to run out, right? You're going to have too many pods densely clouded on your node, and then that's when you have different nodes, and you can add nodes or whatever.
A node is a real thing.
A node is a real thing. I didn't have time to do this, but maybe for another workshop, I was going to try and set one up on a set of Raspberry Pis. And so then you can actually physically see the nodes, and then you can physically see. But yeah, maybe continue.
Okay, so if we can before lunch break, I just want to look at, so we looked at actually deploying the application. I want to now look at how do we deploy an update to application. In this part, we're going to do a bit of an exercise. So we're going to actually change the source code. We then need to rebuild the image and then get Kubernetes to the manifest file to point to that new image. And we will do this by the manifest file, not by the kubectl command. Okay, so what I'm going to do is I'm going to, in my text editor, I'm going to open the image app.js file.
Yeah, don't be frightened by the JavaScript. We'll take you through it.
Yeah. Okay, and so this was written by Alex in ChatGPT, I think.
Jokes were courtesy of ChatGPT.
So
ChatGPT.
So this const surprises is in a JavaScript array where basically each element is one of the possible things it can show to us. So what I want you to do, if you can, is to basically write your own ones here, or maybe just add one and delete the rest. So what I'm gonna do is, and these are basically they're in backticks and separated by commas, and there can be any HTML. So I want to make sure I don't make a mistake. I'm just going to copy and paste the first one, and then change it to something.
So you can also change the fact or something. We do not condone any offensive jokes, so please keep your jokes clean.
Yeah, if anyone does something very clever with JavaScript, that'd be interesting to see as well. So I'm just going to make this changes to a simple text paragraph. Joke.
Let me check.
So it was actually working. Just come on.
List. Either the UPS and in it. So one of the other two. The image is one. So you can't get that image.
Yes, you will have to. Yeah. Do that second. Yeah, if everyone could have maybe just make it so. Yeah, you remove some of the other ones so we can actually see yours without having to refresh loads of times.
Goodness. And it keeps it for about a week, but it'll tell you what's been happening. This is the way, and then the point fix and stuff. So the good word is really keep it. And so you can see yes, there's something you do use CPL. Yeah.
Once we've made the modification, there's a rebuild.
Yes. So okay. So yeah, we should probably move. So hopefully you've had a go to edit this file. Make sure you save it, and then remember if I just redeployed, it would just use the same old image. So we need to do two things. We need to firstly rebuild the image. So that was the minikube image command. Minikube image build. And I'm now going to give it a new tag. Okay, so let's call this local kube chaos. And then this time version 2. And it's going to still use the same image build directory. Okay, so this is the same command I ran before, but I've just changed this to give it a new tag. So this should be faster now because it's.
Would be surprised I'm not getting anything printed out when I do that build.
Yes, you should get something. Build. I think you might have missed the image there.
Oh, do I have the?
So it might have done nothing basically. Because image build.
Oh, okay. The last image refers to the directory that you're.
Where did you run it from?
Yeah, I think that's
I've never thought about that. I'm sad.
You do
So I should answer this.
yes, you need to be in this, yeah. Yeah. You should definitely see some output stuff. Okay, great.
Maybe if it were to raise a warning, you have nothing to do.
Yeah, it just made it just as needed. It's nothing, it's a blank image. Okay. Right, and so the next step we need to do is now I've built this version 2 of the image, I need to now change our manifest file so that it has this image, not version 1. Okay, so this was in deployment, and then manifests. And so on line 19, this is the only change we need to make, is just version 1 changes to version 2.
Slido question, could you review it?
If you have a bug in your version 2, do you then have to make a version 3 and so on? Or rebuild version?
Yes, but you could just delete your buggy version. Yes, so you can do minikube image list to see all the versions you have, and then delete it, and or rebuild it with the same tag. Okay, so make this change to the manifest file, save this file, and then all we do is run the kubectl apply command again, our deployment command. kubectl apply, then it was -f, and then point to the manifest file under deployment manifest. If I run that, okay, so it is work for you. The service and the concrete maps are changed, but we've obviously changed the configuration of this, so it'll tell us that we've configured this.
Yeah, it should.
And also, we've now gone back to 1 replicas because we didn't keep 3 replicas in the manifest file, so this has overwritten the kubectl replicas we had.
I think I've made a mistake, but at the top it says API version, then -v1.
Yes.
And
only on the image will change. Okay. And so hopefully, if you go back to your browser, you should now see your own joke or whatever you put in there.
Great joke. I like that joke.
Well, I prepared it beforehand. Yep.
You find the IP address again.
Just do a minikube service.
SVC, and should give you the URL again, hopefully. Yep.
Now you've got 2 sort of lines in this one.
Yeah.
Is there a way to close that?
So I think it's now pointing to version 2 because that's a manifest file, and I think that's probably a good thing because you don't want it to. You want to know exactly.
It's just another option. The fact that I could do that entirely within SVG.
Yeah.
A little bit tricky.
Yeah. So I would say the solution there is to use something like Git and then version control it, go back to your file, which then you know the timestamp, you know the commit, and that's a much more robust way of doing that. I think that's would be the way to do it.
Longest option to add.
Oh wow.
Nice. SVG.
Okay, great. Yeah. Great. Yeah, I was on the.
I've been answering.
Want me to say it about them?
Shall I wrap up?
Yeah, that'd be good. Yeah.
Right, so there have been some questions on the Slido, which I've answered in the Slido for anyone who's interested. This is a good time to pause and stop for lunch. Thank you so much for your participation. This is the first time we've run this, so sorry for all the little debugging. More fun with Kubernetes. So this has been like pulling teeth. I'm going to run out, grab some sandwiches, and then I'm going to be in the room to try and help answer any questions on setup. Piper will be here too. So please come back after lunch, and then we will be joined as well by the lovely Alex. So there'll be even more in the room for us to run round. And I think he probably knows more about it than us 3 put together. So we'll have a real expert. So yeah, please come back this afternoon if you like for config maps and help and fun. And thank you so much for your participation. For those of you who aren't planning to come back, I just want to say this has all been possible through the fund of the Software Sustainability Institute. I'm a fellow this year and I'm trying to start the Cloud Native SIG. So at the end of the day, I'll go for a little bit more about what that is. Thank you very much.